All right, Go Component Lab, welcome back. So as scheduled, we were going to be doing a abstraction for multiplex streams. There's a handful of protocols that at their core are pretty similar in terms of providing multiplex streams. To name a few: QUIC, SSH, HTTP2. Really, that's it. There's we've been working on our RPC system on top of QUIC, called QRPC at the moment, in my prototypes repository. And it's built on QUIC, but we actually already started the abstraction just because I've worked with these a number of times, and this is a really lightweight abstraction. And so if we wanted to do something that was a little bit more general, maybe we would do something a little bit more in depth, like the actual interface for QUIC itself, which is closer to a net con interface with read and write deadlines and cancel writes and stuff like that. But it's better to start with the simplest thing first. Another reference here would be Alan's Muxado, and this library is basically a very similar interface. And its implementation is on HTTP2. And in fact, I'm not sure if I want to do HTTP2 or just Muxado, because a lot of the time these libraries don't actually implement what the protocol is really capable of. They give you something super high level. For example, in the Node.js world, they have an HTTP2 package built in, but it does not really give you the ability to use it without the very HTTP specific stuff. Whereas you can use HTTP2 without headers and any of this stuff, because it even though they're not explicit about this layer like they are in SSH, you can just use it to multiplex streams. This Go one, I'm not sure if we could do this. Let me look real quick just to see. Client connection. Yeah, this again is hiding all the kind of lower level stuff, I think. Actually, there might be a not HPAC. I was hoping they had like a transport layer or something. Oh, they have a transport here. Let's see what we have. Serve connection. Does the server let us handle incoming streams? See, in from the perspective of the top of the HTTP2 stack, opening up a stream to the client is called a push stream, which I understand, but at the protocol level, it's fairly symmetrical. It's just a stream that you open, like the same stream that you open from the client to the server to download a file is the same thing that the server does to the client on that same connection to open up a stream. So it looks like this one too is very coupled to the HTTP2 idea, and they're not exposing the lower level stuff as well. So without a lot of work or figuring this out or something, I'm probably going to have to do Muxado, and we'll call that HTTP2. Muxado is not all of HTTP2. It is just the framing layer. He says it's influenced heavily. It's pretty much the framing layer from Speedy or HTTP2. Although, let me do a Google for Golang HTTP2 framing layer. No. Oh well. So we'll say HTTP2 even though it's not entirely HTTP2. SSH though, we can totally do. The Go, and I'm not talking about my SSH library, I'm talking about the X crypto SSH library, which is a client and a server, and gives you everything you need to open up streams. Right, a session, combined output. Let's see. I guess it's not on the session. We would say new server connection. Where's our client? All right, so this connection type is shared by server and client, and you can think of this as a transport. We'll ignore requests because we don't care about that, but here we open channels. So this lets you open up a channel to the other side. Handling channels, now where's that? They're equivalent of accept. I've done this all before, so I know it's here. Handle channel. So on the client side, you can do handle channel and you get new channels. So that's like an accept on the client side. On the server side, server connection. So it's like a normal server, except when you get a connection on it, you do new server connection, which will ultimately give you a channel, a Go channel of new channels that you can open and accept. and then we can kind of ignore everything else. I also want to do a transport, maybe not on this stream, but I want to do a lightweight multiplexing transport that is really simple to implement so that you can use it on other streaming transports like WebSocket or raw TCP, just so you get those multiplexing sub connection or sub channel semantics, because we'll definitely need that from JavaScript, and ideally we can use it from the browser. So doing something over WebSocket is really ideal. So I guess we'll start with SSH. And our goal is to get something like this. So let's open up the project. Close out. And earlier today we implemented this nice new API for the RPC layer. All right. So transport, we'll create a new file called interface that we can move these interfaces to. And kind of reorganize this a little bit. So it might not be this simple, but that's the idea. We're going to do one for SSH. We'll actually grab all of this as a reference. We'll call that a connection. We'll call it a session. Because SSH has sessions, which we're not exactly using specifically, we're just using their connection. This makes it look like it's going to be real easy. But it will be a bit more work, I'm pretty sure. All right, we still have more stuff, but this is kind of a rough pass. Let's see, I still don't have a great library example. We did do a library a long time ago under GL prototypes. We can kind of use this to get us going. So we'll take an SSH config, which is the only thing we need. They say often you want to return the pointer to a particular type, but I guess if it's not a exported type, then you should use your public interface. I've seen both ways. And this is the core of it here. So we do a bunch of stuff because we're dealing with sessions, but we're not actually going to be doing that. We just want to get, let's see, where's our client? Client, which has this. So we can open channels, and it had handle open, channel open, which we kind of want to wrap into like an accept. So that'll be interesting. We have to kind of do a little bit of transformation on that to make this work, but yeah, for the most part, let's see. So we'll make this a client, SSH session. We might have to do something different, depending on whether it's a client or a server, because handle channel open when you have a client is different than on the server. So let's see here. We'll do it as a client to start with. We'll take an SSH client. SSH session client. All right, so that's working so far. SSH session doesn't implement. Right. We are kind of avoiding doing stuff with context, but I wanted to have the it part of the interface. So let's actually do this then. This is pretty straightforward. We can do close. All right. Yeah, I think we might do two different types for a client and server just to simplify. So client, or rather connection. Open channel. You don't have to have names. Basically, channels can have in SSH, they can have a name. so that you can see what it is on the other end and decide whether or not you want to accept it. Modern stuff doesn't really have that, and I guess ultimately it is kind of unnecessary, so we'll just kind of like pretend it's not there. I'm wondering if we can do an empty byte stream or nil. What's the deal here? It's not clear. I'll do an empty byte stream. So this gets us a channel, a bunch of requests that we will have to discard. And then basically from there we can just have our SSH channel. This is an interface, isn't it? Yeah, so I don't need to do that. Channel's missing a context. Oh, we want to pass our context through. So we've got open working. This one is a little bit, I'm thinking we're gonna have to start a Go routine. Channel type. Well, actually, it's a little bit simpler than I thought. So we can store this channel. Chams. New channel is this weird intermediary interface that you use mostly to accept or reject. So it's, you could almost think of it as like a channel header type of thing. Yep, welcome back. Alright, it looks like we could handle channel open. We're just gonna use empty strings for the channel type. Hopefully SSH is okay with that. This library should be at least. So accept now is basically us listening on chans, waiting for the next one. which we will basically always accept. Channel request error. We might even want to just do this. We will discard requests. An interesting SSH is a very interesting protocol. But at this point, now we have a channel, so we can basically do this. So a channel, let's see how much of this implements our stuff. It's a reader, writer, closer with some extra stuff that we don't really care about. So that's actually fine. We can just embed that, and then we don't have to worry about read, write, close. We just have to implement context, which we have done, and ID, which we don't have any way to identify this. It is not exposed here. We could create our own identifier, but I know it's in here. Oh, maybe it's not exposed. Maybe new channel exposes it. No. Session ID is not what we're looking for. Yeah, I don't think we actually get an ID for the channel. So I think we're gonna have to make them. I know there's a counter in here somewhere. Did I do the counter properly? I did not. So you do this modulo the size of the data type, and then it'll loop around. Let's see, we will have an ID. Let's see, since we aren't given an ID, if I recall, both sides have a unique ID for a given channel. So we can share a counter. We probably want to increment that atomically. You probably don't need to do a mutex. We can just do a what am I thinking of? Atomic. Is it really just value's cool, but I guess yeah, I guess you just straight up call it. Just like, what's it doing? What the fuck? These are just the descriptions. What's going on? I'm guessing they all have, yeah, different. Yeah, so there's a different one for everybody. So if I wanted to see, oh, I don't know. Okay, so they just fucking do it here. All right. If you use the architecture, you might have to leverage the kernel, right? Yeah, I mean, I've seen these used before, but because they don't actually have like instructions here, I might just want to do it with the fucking mutex. We'll start servicing them before that. All right, so that implements our channel interface. Now, this listener stuff is kind of dependent on how we do the server. Let's see, what do we got here? Because it wants a counter. We can initialize it with 0. That's totally reasonable. What? I guess we'll just do it by name. It always happens. I should just always do it by name. We can use the 0. That's fine. All right, so now we want to do this server stuff, which is what my library mostly does for us, but I see. So we can actually use a regular listen here. A server config, SSH server config. That config is not actually used until we set up the connection, so we'll put this in our listener. But we're gonna do other stuff, so let's hold on to that. Whoops. Then we're gonna do this. Look at all of this. Oh, we actually get us all the channels here as well. That'll be interesting. We already have this connection. This is our so we're getting there. Basically this again. So, I think we're gonna have to create another one of these. Let's see. Well, actually, now that we have a channel of, those are new channels, right? Oops. What am I looking for? Yes, a channel of new channels. In theory, we could actually use the same thing. So we have that. This is fine. Open channel, if this is a connection, then we can do that. Alright, cool. This is actually, it is very generic. We just do that instead. And we can use it for the client and the server. Got Chans and our context. Ooh. They made different types. What's our server connection? What's so different about this server connection? I forget. Permissions. Well, we'll just grab the connection from server connection because we don't care about permissions. Isn't that the same now? Yes. It's an interface, so we just want that. Okay. In theory, we could actually use this to do some RPC now. We would have to change this listen and serve to use our other one and come up with some better, we're kind of just doing a baseline thing, so we might do the same thing here. Generate SSH client config. We'll grab a client config from here. What is the username we should use? Doesn't matter. Let's see, we're doing, let's do no auth. Where is it? No client auth. No client, clients are allowed to connect without authenticating. Which is fine for our case right now, kind of a demo thing. But I want to make sure our client config can just be like an empty auth, or if we have to say like explicitly no config, no auth. Okay, we could just leave that empty.
Our server config, though, let's see. No client auth. That's pretty much it, actually. We do need a host key, though. We can probably... Here, I'm gonna hit up our SSH library, because I think we have that somewhere built in. Let's see, it wouldn't be an option. It's like a default if we don't provide one. Host key. Here we go. Generate signer. Where is that? Util. I guess we could actually just... if we can't generate this, this is kind of a temporary thing anyway. What? Oh, we got an error. We have to check for an error there too. All right. Well, what's your problem? That's right. We were in the middle of this stuff. Okay, so in theory, we can just do this. All right, and then our client. Replace this line, and we can come up with a way to kind of make this more pluggable, but for now, just to make sure it works. We should be done. Our RPC system should work just as it did earlier today. Get rid of that.
but it would be using SSH. So let's try it out. Go run demo. All right, we fucked something up. We didn't actually, what is this? We didn't actually check the error. Is that true? We're accept session error, and then this is used by our listen and serve. Wait, it returns an error, but we're probably not catching that, so we'll put that in it thinks it's listening. I mean, unless it's not, and we're getting kind of a weird race condition. I can imagine the UDP one, you wouldn't have this problem, so let me just do this, something really stupid. Okay. There's our RPC system that we made, working over SSH. It's interesting because SSH is doing a ton of stuff, ton of kind of crypto stuff to set up, so it would take a little bit, not 1 second, but just like not like immediate. So I can't think of anything that's like smarter than this that's worth doing at the moment. We could do something, or we strobe a signal or something. Let's see, listener accept. mean, once we're listening, I'm gonna do a little experiment here. Oh, did I make it receive? I did. Why did I do that? Just wait. Oh, we didn't make it. We didn't set it up. Close vanilla channel. I don't want to create a constructor for this because this is a stupid little thing. So, we could do. This is what we'll do. I'm probably gonna throw this away. I just wanted to like put this in here for this. Okay. Here we go. So that's a way to do that. I'm curious. I guess if you're doing testing, you could break out the listen part and then listener's not going to have anything fun. And we could put this listener on the server and then basically poll for it to not be nil. Trying to think of a way that we can implement this that isn't changing the API in a, in a way that's specifically like, I don't think I necessarily want to do this because only having this method of doing listen and serve is sort of a short-term thing. So think it's not super uncommon for. Let's see, can we get the listener for an HTTP server once we make one? Okay, yeah, I guess not. I mean, might as well just implement serve so that we can do that. Then we'd have more control, because that's kind of the reason why I was putting that off. What? Transport listener. Oh yeah. Yeah, we just make that this now we can do this a little differently. We can I mean, this actually, by not doing the listen in here, that sort of allows us to not have to do like a pluggable thing where we give it a string of what type of transport, because we can just make the transport before. So I'm interested in actually just getting rid of this. We'll see. The client might be a little different, but now we need, I mean, eventually we'll have all of this in our demo where it should belong. It's not, these aren't library functions, these are demo functions. It's not what I was hoping for. Here we go, panic. So now, because to listen, I think is the thing that takes up the time. So now that we're doing that inline, we should be able to dial it afterwards pretty immediately. So that solves that. We should be able to run it. So if we wanted to do that for the client, though, let's see. Client dial. Dial gives us a session. And then we can just make our client from that. So we'll see how we can do without these in here. Right. So there we go. We could switch back to QUIC. Pretty trivial now. I think listen, QUIC. We need a QUIC config, generate TLS config, and then nil, and then dial QUIC, TLS config, and no config. Right, should work. Ooh, that's right. We had a where was it? Another option here, TLS config. Yeah, we didn't give the client the same config. So there it is running QUIC. And here it is running SSH. And we have an hour to kill. So I was originally thinking that this would be a little bit more in like an API design exercise where we could create an abstraction, you know, library. But this transport library almost is. In fact, we could name it something like Mux Transport, and it would be a pretty usable generic package. It almost seems too easy, right? That's how it can be. Let's see. So we talked about HTTP2. I was thinking of doing Muxado. Because that should be relatively quick. No pun intended. What do you think? Should we rename this to Mux Transport? Anybody have thoughts? Muxado, Muxado. I forgot how he says it. And again, we'll, because it's going to be very similar to QUIC, so the API is very, very similar. Very, very similar. I don't actually think we have this. Does he call them streams? I think he does. Well, he actually treats them as connections. That's fine. But I think he implemented a connection interface. No? Maybe not. This implements the netcon interface. So might as well just use stream. Stream, channel, same thing. Here though is more like SSH, where we're just keeping a net listener. I'm not sure what else we'll need, but all right, so we can just dial whatever the hell we want because he doesn't do any of that. I love libraries like this where you just use, you know, the net package and dial whatever you want, and then just take the connection and here we will run this protocol on this connection. It is pretty great, which is almost what I'm doing. Let's see, his close doesn't need. Okay. He also doesn't have a context, so we'll have to copy that from SSH as well. Open. Well, I mean, it's a stream. Accept, same thing. His stream ID though, you went to 32. What? Cannot use Muxado channel literal. Is type channel because it doesn't implement channel because it doesn't have missing close right. Wait, what? Oh, we're just missing a context method again. Like SSH. Since it's based on HTTP2 and there are IDs, yeah, we don't have to do IDs, but we do have to do contexts. Just so they're there. Okay, okay. Picky. Now what are you complaining about? Oh. Now what? Channel does not implement stream. wait. We're getting, okay, wait. That's a Mux2 session, so we should be getting, connection does not, yeah, see this, okay, so, and we don't care about that close right. So but we know it's a stream. We know you're a stream. What? Okay. Oh, okay, I was leaving these for last, I guess, so, okay. Blah, 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 we don't have to do that. Same thing, we don't really do anything special here. Except when we accept this connection, we turn it into a listener. We say session. What do we say? Client? Really? Okay. Oh, because there's something in the HTTP protocol where it has a flag on whether you're the client side or the server side, because even though the framing layer is symmetrical, the upper level stuff is not. So there's no reason why he had to implement this, as far as I know, other than to comply with the HTTP2 stuff that he was doing. What is our config here? Do we need a config? Oh, there's defaults, so I can just do nil, I'm pretty sure. That tracks? What else? What's wrong? Too few values instruct initializer. Looks out of session. Oh, because we need a background thing. Our listener doesn't have one. Did we do that for SSH where it has a context? We didn't. I don't know how useful that is. All right, so all this stuff works. We just have to do this, and this is the easy stuff. We probably do want to do a config because he has a config. Let's use our client config as well. I guess there is a config either way. So config muxado and here's the config. So now we're all fine except for the listener part, which is pretty trivial. Right, and then we have dial, which is also quite trivial. We'll do a net dial. I feel like there is some place where I did not return the error. Is that the case? Okay. What's to do client connection and config, and boom, we're done. We could change our demo now. Dial muxado, and we'll see what errors in muxado we run into because my code is fine. Okay. First try? First try. So that is HTTP2. But we'll call it muxado just because. Let's see. And we still have 35 minutes. Could we invent a protocol in that time? I don't know. I wanted to do a protocol that we can do over WebSocket, right? So based on SSH. Or more or less like looking at their channel connection protocol layer, doing kind of the minimum viable for them, which I think is simpler. It has flow control stuff, but I think is very easy to implement. It's interesting. I don't think we need to have confirmation of failure that's something that SSH had. Remember, we had that new channel and we had to accept or reject. HTTP2, it just always accepts, and so we might as well just do this. This always seemed like an unnecessary step anyway, because it's like, just close the connection. If you want to have an error, do it at a higher level code. A lot of old protocols do this, though, where they implement, you know, because they just haven't got to the point where there are higher level protocols that they can kind of assume will be there to provide this kind of functionality. So, I mean, just like modern data format stuff, like protocol buffers and JSON and message pack, like we have a standard set of primitives for data types. We have no reason, people rarely have a reason to come up with their own data serialization protocol, but almost every protocol of, you know, 10 years ago and earlier was had its own marshalling protocol and format. SSH does too, but now we don't have to do that because we can use, there's some really great ones out there. So we can ignore all this. And we ignore extended data. This is how they send standard data on the same channel. Closing a channel. So basically we have 1, 2, 3, 4, 5 types of messages in our new protocol. Why don't we start writing that up? Because it's a protocol, maybe it's a good idea to start with a spec. We'll call it netmux. Hell, let's call it QMux. So let's just take the stuff that we want. Implementation I expect to have some limit on the SSH transport layer packet size. Any limit, we'll just hard code that in there somewhere. Right, and we won't do extended data. Closing a channel. What else? These are all request stuff. We don't do any of that. And everything else is built on top of those primitives, so let's see, global request. Yeah, that's pretty much it. So let's start simplifying this a bit. English is harder than code. Multiple channels are multiplexed into a single connection. Either side may open a channel. Connections or streams. Number requests to an open channel. The number referring to a channel may be different on each side. Requests to open a channel contain the sender's channel number. Any other channel related messages contain the channels of flow control until the message received. Okay, it allocates a local number for the channel, and it sends the following message to the other side and includes the local channel number and initial window size in the message. So we can replace this with kind of a message pack sort of data structure. Or actually, no, I didn't want to do that. Did I want to do that? No, I actually wanted to do, I think, something like this, just because then you don't need any serialization. These kinds of protocols are fine. So this is, if you did a complex nested format, whatever it is, you should use message pack. If you're just storing like a little bit of extra metadata or frame data, and it's like a well-defined size, just storing the actual bytes is and defining the byte structure is fine. So these are defined somewhere. I wonder where these are defined. Did we just pass it? Oh, here they are. We could just do a literal. Zero. One. 2. 3. 64. So we actually got rid of the channel type stuff. So this is all there is. So you read 1 byte if it's 0. Read 3 unsigned integers. 32 though. Let's bump it up to 64. So I can get rid of this sentence. Is it smart enough to do something like format? Maybe it'll format this. Come on, man. Okay, maybe not format, but do that thing that good editors do where they just like fix the width. Do I have to open another editor and hit a button just to do this? Format. God. What do they call it? Reflow. Reflow? Okay. Oh, it made it wider though. If I change that, what do you think it is? Those are tabs, so whatever. Both parties use following message to adjust the window. The recipient channel. Bytes to add. Okay, so here's where how they define a string. It's usually going to be a sized. Where do they define a string? I think they actually put it in the other document. This is the best way to write a protocol. Just make it a subset of an existing protocol, and then you get like a spec for free, basically. Strings are allowed to contain arbitrary binary data, including null characters and 8-bit characters. They are stored as a uint32 containing its length and 0 or more bytes. Strings are also used to store text. But we don't store text, so let's just do that. An 8-bit. Let's make this bigger. Alright, so that's expected to have some limit. Must not advertise maximum packet size that would result in transport packets larger. Must not generate data packets larger than its transport layer is willing to send. I don't know why that is. I feel like we could just end right there. You know, maybe I want to have these just because it's so much easier to read. Did I already? Here we go. No, I'm looking for this now. God damn this. I don't want you, Adam. So we'll say we get rid of these. All those. We had data, EOF, and close. I'll just grab those. I wonder why they started there. Hmm, 20 messages, 80 through 100. I don't know why that is necessary. Be more clear. Message number, byte value. Just wondering if there's any reason not to use 0. Because is that like a null byte or something? The null character has a code point value of 0. So let's not do that. I don't know. Let's start at 100. And even though we're not doing closing streams, you know, we'll put it in there because we probably will eventually. When a party will no longer send. I don't know, 8's a lot of bytes, but Might as well future-proof. And what's 8 bytes today? Ooh, must send back a close. And then it may reuse a channel number. Well, that's basically it, man. I don't think if anything else needs to be defined. Feels pretty good. In fact, QMux spec. I guess it's about time to do a recap. Spec. Sweet. Oh, we missed that. Okay, time for a recap. Let me try and do this right this time. All right. So here's what we did today. We've been working on this QRPC prototype, and earlier this morning we actually got updated its API and have a pretty happy with the API. But one of the things that we did going into it was set up an abstraction for the transport. So we created this. These interfaces to define a multiplex transport that QRPC is based on. And so this is nothing new, and our initial implementation of QRPC was just QUIC. Did we lose a QUIC implementation? I must have killed it somehow and not QRPC. For some reason, it's here. If I close this and open this. Oh, I'm scrolled down. That was nutty. Anyway, so and we did an implementation based on QUIC, and it was pretty simple because QUIC's API is pretty similar to the interfaces that we defined. And we created these dial QUIC and listen QUIC kind of constructor type things for either dialing or starting a server. So what we did today was try and use this abstraction and implement a couple other protocols that are already doing multiplex transport stuff, and to see that our abstraction works, and then actually see the demo run. So we implemented SSH. It's a protocol that I know pretty well. And we have a pretty good library. It does a bunch of stuff we don't care about, like requests. And when you open up a channel, you can provide them a name. But we basically create a convention here where we don't use that stuff. So doing this, we were able to create an implementation here, a session and a channel and a listener for SSH. Just using the API a little bit here and there, and then creating these, which is a little bit more kind of setup work, but we did it. And then we threw that in our demo, and so we can actually try that here. We also changed it so that our demo calls the transport methods directly, and then we pass the session that we get from them into our client or server. So QRPC go run demo. So assuming this is saved, this is our bidirectional RPC that we've been running a little bit over the last couple of streams, where both the client and the server connection call each other. And so it's showing the request and the response from each of those. Okay, so dial SSH, and we're like, great, and we can switch back and forth between that and QUIC, and none of our other code has to change at all, and the thing runs the same. So then, and I mentioned HTTP2, but because HTTP2 at a high level is very focused on HTTP-like request response stuff, even though the lower level framing protocol is a multiplexing layer, we couldn't use the HTTP2 library to do what we need. It just doesn't expose the low level stuff, and has all this other stuff that we need. So instead of HTTP2, we used Alan Shreve's Muxado library, which is basically a library around just that framing protocol. So it's sort of HTTP2, but in a nicer library. So we then did an implementation of that, and again, it's very similar because its API is pretty much the same thing. You know, ultimately, it's like you get a session, and then on that session, you can either open a channel with the other end, or accept and wait for the next channel that they've opened with you. So it's very simple. And then the channel, of course, is pretty much just a read writer closer, and so you can treat it like a connection almost. So again, this was very simple, and we were able to just drop it into our demo. And run that, and it works. So we have 3 different ways to run this RPC system. Of course, the interesting thing is that none of these are things that we can actually do from a WebSocket, or rather the browser. Even though you can do HTTP2, you don't have the low-level control, so you wouldn't be able to use Muxado. Maybe someday QUIC, I don't know, but probably not the low-level stuff. I don't know, maybe. So I decided that it would be a good idea to create a very lightweight muxing wire protocol, and the idea was it can be based on SSH. I've looked at all these protocols, and they all have pretty much the same semantics of, you know, prepending your messages with a channel ID, having open, having close, and then ideally having some kind of flow control. And so the SSH connection protocol layer is very simple. We simplified it even more here, and what's great about doing this is that we can just take the spec and just take the part that we care about, because they go into, you know, SSH has these requests, and you can do global requests or requests for every channel, and you know, extended data, so that you can do standard error. We don't really care about any of that. So I basically copy and pasted just the stuff that we wanted, and then modified it to not be specific to SSH. And so what we got here is a pretty nice little spec. I mean, this is a pretty simple document. It looks like this. It's basically defining the wire protocol, which makes it very easy. Like, this is a very just like read a byte, read 8 bytes, read 8 bytes more. You know, we have a string defined here. Here's how those data types work. You know, the byte, the message type bytes are all defined here. Really just copied and pasted from the SSH RFC and got rid of anything that we didn't need. And what we have here is a pretty sweet little, easy to implement multiplexing or muxing protocol that you could use over TCP, you could use it over a WebSocket, you could use it over pretty much anything. So next, we'll probably do an implementation of this in Go, and then create another transport for QRPC based on this. And then we will probably get into some JavaScript stuff or do more of the reflection stuff. But so that's what we did today. Thanks everybody for hanging out and watching. If you're watching on YouTube, leave me a comment, tell me what you like about these, or just say hi. Love to hear from you. And otherwise, see you guys later.